Assalamualaikum and hi.
My name is Megan Singhi.
My name is ECH3115.
My name is Umar Adam.
Matrix number 188647.
188774.
192.
I will presenting on our crystallizer, continuing from our first semester material balance design project. So our crystallizer have a sucrose recovery of 0.74 and also other sugar recovery 0.4, and water inside the sugar crystal, which is also sucrose and also other sugar, is 0.01, also in other words 1%. The solubility of sugar is 71.7, and the solubility coefficient of our molasses is 2.5. We get the amount of water in sugar. Our sugar is by adding 1% from sucrose and also 1% from other sugar. And the amount of sucrose and other sugar we get from the sucrose recovery percentage and also other sugar recovery percentage. And our molasses, we get the water from by adding the amount of water from the amount of we get it from the amount of sucrose added by other sugar divided by the solubility coefficient, and then we get the amount of water inside the molasses. And the impurities we just added up from the previous from the filter we got, and we just added up into the impure. Next we'll move on to the separator. Our separator will from the stream 20, 21 and 22. Stream 21 is the molasses. Also from the separator we have the percentage of 0.1 molasses recovery. So here we have 0.1 maybe 0.9 molasses, and here we have sugar plus 0.1 molasses. Continue on the boiler. So this is amount stream 4 is the amount of boiler that have we produced. Stream 4 from the unit operation of Miller. So we get the bagasse in stream 4. So we use the bagasse into the boiler to produce steam. And here show that we got some amount of bagasse. From that amount of bagasse, we get this coefficient from the internet by inserting a formula. So we got the ratio of steam and bagasse from the impurities of the purity of bagasse inside this. So by using the formula, we got that 0.94 of steam will produce if one bagasse is used. So by using this equation, we got the amount of steam produced.
So I will be presenting about dryer. So for dryer we have hot air in. So the mass of hot air in is we take 2% of the mass coming into the unit. So this is the mass. So we times by 2% and we will have the mass of the hot air. So we want to have the fraction of the sucrose equals to 99.7. Back calculate it. So we divide the flow of the sucrose we get from the stream 22 and we divide it with overall. So we'll get this. From here we will get the fraction of the water coming out from the stream 25. This water, it will come out from the stream 24. So this is what we get for dryer. So I will be explaining about the miller, the energy balance formula. Okay, so we just do it as usual. We calculate all the H dot using the H cap. H cap is we multiply the CP values with the temperature difference, and this is what we get. And for miller, we also have the WS. So we just add the delta H we get, delta H output minus delta H input plus WS. So we will get negative 162.459 kilowatt. So for heater, it is just delta H. Same as just now, we use CP times difference in temperature. So we'll get the delta H cap. From that, we will get the H dot by multiplying the H cap with mass. So we get 145,000 kilowatt. So for phosphate mixer, it's also the same with heater, but we have a reaction here. So we will be using delta H, Q equals to squiggle delta HR plus delta H. So we calculate the squiggle, we calculate the delta H using the heat of formation of the reactant and product, and this is what we get, 500 kilowatt. So for liming, also the same, we have reaction here, so we use the equation to have the delta HR, and we calculate the squiggle and we just multiply and add all of it. So we will get the Q equals to 73,000 kilowatt. And for clarifier, we just use the CP values and multiply by the temperature difference, and we will get the H cap, same as just now. So we get negative 26624 kilowatt. So for filter, also the same because we have temperature difference. So we calculate just now and we get negative 176 kilowatt. Okay, and then for heater, also same as our heater one. So I think I don't need to explain. For evaporator, here we know that the water evaporates come out from stream 17. So we first do the hypothetical path, and then we calculate the delta H for vaporization. We add all it, and this is what it came out. And we just multiply, and we'll get the H dot. So the other one, we just do it as usual, and we have the H dot. So we add all, and also we have steam here. We just get the H cap steam from the steam table, and we add it all, and we will get 251 million kilowatt. So for crystallizer, it is quite same. We will have this. We will have the hypothetical path, and we just we will get 1300,000 kilowatt. And then for separator, we have WS here. So it is 0.12 kilowatt for 33.57 kilogram per second. So we just add the delta H and the work shaft. So we will get negative 513 kilowatt. And for dryer, we just do it as usual. We also have WS here because we use rotary drum dryer, and we just add the delta H value with the work shaft. We will get negative 1803 kilowatt. And okay, so lastly for boiler, we must first do the hypothetical path, and then we will get 3179 kilowatt. And then for pump, we only have two pump. First is this, we use Q equals to delta H equals to V cap delta P, so we get 1446 kilowatt. And for second pump, we only have 0.51 kilowatt because we just have small difference in pressure. Thank you, that's all from me.
Now we are going to look at costing. This is a list of equipments and its price that we need for this design. And we also have put the number of units for each equipment needed to accommodate our production rate of 1.5 million tons of sugar cane per year. The number of units are all calculated in accordance to the capacity of the equipment we found in our references. So using the conversion rate of 4.6 USD to Malaysian ringgit for some of the units that are only available in USD. Now for freight and transport, we estimated about $40,993,132.40 MYR, and our ISBL is 860,855,780.4 MYR. Our OSBL is 344,312,312.16 Malaysian ringgit. Our design and engineering is 516,513,468.24 Malaysian ringgit. Our contingency is 430,427,890.20 Malaysian ringgit. And so this brings our total fixed capital cost to 239,451 Malaysian ringgit. That is 2,152 million ringgit. As for working capital, it would be 322 million. Yep. And so our total investment would be 2,474 million. It's about there. It's just an estimation. Okay, so for our yearly plan, we would start profiting at about year number 14. Year number 14 is right there, and at first we would lose money, but after that it will keep rising over the years.